Okay, last time we were talking about the smush function because I gave you a job and what you had to do was, if I give you a positive number, you're to return half of that value. But if I give you a negative value, you're supposed to give me just that value back. But you couldn't do it because as of now, we had no way of making a decision in our code. We've got variables, we've got types, we've got, we've written functions and whatnot. But we know about Booleans, we know about Boolean operators, we know about comparison operators. The Boolean operators being like and, or, not. Comparison, are they equal, greater than, less than? But we had no way to provide control for flow in the program. There was no decision-making process. And then we talked about the if statement. And there's the if statement. By the way, is the windows being open blowing out the, can you see it pretty good, or is it here? That'll probably help a little bit. That's helping, right? Yes, no, it doesn't matter. Oof, it's pretty dark. Is that better or worse though? Worse? Worse than this or worse than when the windows was open? Worse than the windows? I can put the windows up a little bit. Tell me when. That's pretty good, right? All right, there we go. So yeah, we had the if. First, I really need to reemphasize, this goes for the asserts, this goes for even the Boolean operators, really any operator. But the if, in this particular example, I say if a number is greater than 0. But the if, really, ultimately the if is acting on that statement. Ultimately. But really, if only wants a true or false. It doesn't care if it gets a statement or not. It just needs something that evaluates to a Boolean, true, false. One of those two. That's what the if wants. The if doesn't really care that it says a number greater than 0. All it cares about is that true or false? If the condition returns true, we see if true, we go inside the if and execute the code. If it was a false, then if false, we just skip everything in that if entirely. This is where we're going to have that branching decision making. Now let's walk through the code. And by the way, I emphasized this to the other class because I think they thought I was being demeaning or something. But when I'm going through the code line by line and I'm getting you to say stuff, I'm not doing that because I'm treating you like you're children that can't understand. I'm doing that because that's what we are you need to execute this code line by line in your head. This is a skill you need to develop. I'm not doing it to be mean. I'm doing it because this is what we got to do. So let's follow this code. I call smush with 10. So when I call smush with 10, what value does the parameter a number take? Come on, wake up. That was slightly better. Keep waking up. What value does a number get? Perfect. Then line 10 is the first line that's going to run inside that function. Return value takes on what value? 10. Come on, wake up, wake up, wake up. So return value takes on what value? That's much better, but it still sounds like you're not willing to cooperate. Come on. Then I ask, okay, a number greater than 0. So what value is a number? Is 10 greater than 0? Did someone say yes? Did he say yes? True. Okay, you fixed it. If that condition is true, which in this particular case it is, we actually go inside that if. We go into the indented code and we execute it. We see return value equals return value divided by 2. But what's return value right now? So what's 10 divided by 2? Where do we put the 5? Return value. And then we return that value. Good. Well, let's do another one now with the other case, negative 10. So, negative 10. What value does a number take? Return value is then equal to a value. So what value does return value have? Negative 10. So is a number greater than 0? False, because a number is negative 10. So I skip the code inside the if. I skip all of it, all one lines of it, and I just jump down to return value, which is negative 10. We return negative 10. If you're looking at this code and you're thinking to yourself, well, why didn't you, like this whole use of this return value, it's kind of unnecessary, right? Because you could just do this. Whoop, that was weird. And it works just fine, right? I saved a variable, I saved a line of code, fine. There's nothing wrong with the code like this. But I like the code the way it was. Because there's a couple reasons why I like the code the way this is. First and foremost, a number was the parameter. It was a value that the function got. And although it didn't matter, I could change the value of the a number parameter. It doesn't really matter in the code. I kind of like the idea of leaving it alone, right? This function received this value, and I'll remember that. I'll store that value in a variable, but I'm not going to touch that variable. I'll just leave it alone. And the function is supposed to check if a number is greater than 0. So I'm doing the comparison on a number greater than 0. But I could have just as easily said return value greater than 0, because a number and return value have the same value from the line above. And again, they're functionally the same, but in terms of the code being a little bit more self-descriptive, you know, the task was to check if the number it got is greater than 0, is positive. So I wrote that very explicitly by saying a number greater than 0. I realize it would be functionally identical, effectively even meaning the exact same thing if I said return value. But I'm really choosing how I write the code based on the variable names to make the code as descriptive as possible. There would be nothing wrong doing it the way I just showed you with one variable. But I just like this one a little bit more. I find it a little bit more clear, a little bit more explicit about what's going on. Yeah? We could absolutely do that. You're absolutely right. In fact, maybe that makes sense. In fact, I do think that makes sense. Perhaps this is a better one, because really it's supposed to be a number divided by 2. You're absolutely right. So in fact, this is an even better version of the code. Good catch. Now the code is even more descriptive. It's a number. It's half of a number. Taking half of return value does the same thing as taking half of a number, but in the spirit of what the question was, we were halving a number. Great catch. Okay. Was there any questions about that code or anything we've seen here so far? All right, so here I'm going to give you a minute or so to do this activity. Write a function is negative that returns true if a number is negative and false otherwise. Okay? Just give yourself a moment to do that. I'll give you like 2 minutes to do it. Your call. Is it negative? I'd probably say no. Raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. Okay, take the time. Who here did it like this? Raise your hand really high. Yeah? Now, who here looks at this and goes, well, that's weird. There's 2 returns in that function. 2 people think it's weird? 3? Well, turns out this is absolutely fine. Your function can have as many returns as you want. But only 1 will ever get run. So let's run through this particular example, and we can see how it would work. If I put in a -1, I check, is a number less than 0? Well, is -1 less than 0? True. So we go inside that if, and then the function hits the return true. So it hits return true. And whenever your code hits a return inside of a function, the function immediately stops. Nothing else will happen. If we put in 1, is a number less than 0? No, it's not. It's false. So we skip what's inside the function, we go down to the second return, and then we return false there. So it is entirely fine to have multiple returns in your function, but be aware that only 1 will ever actually run any given time the function is called. So just be aware of that. This is actually a really terrible way, though. So, and I will say, some programmers feel as if your function should only ever have 1 return. No matter what, you still only write 1 return. It's easier to keep track of where, like where it could exit from. So a way to do that would be something maybe more along the lines of there. So now, did anyone write it like this? No? Well, this is another way to do it, but now I only have 1 return. I assign a variable return value to false, and then if the number is positive, or sorry, if it's negative, then I just update its value to true. If it's not negative, I leave it alone. Sorry. I start it with false. I'm getting mixed up if I'm doing if negative or is positive. I start with it being false, and then I check if it is negative, update it to true, but if it's not negative, just leave it alone and then return it in the end. But this is entirely fine, it's functional and whatnot. Did anyone use that fancy else keyword? A couple people? Well, we haven't seen that yet, but we'll look at an example like that. You know, I just showed you 2 ways to write this function. There was a third way. There's another way I'm going to show you in a moment. But look, with such a simple function, look how many, like, obvious ways or simple ways there are to write this function. Students are always wondering, like, well, if we're all working on the assignment and the assignment asks us to do ABC, shouldn't all our code look the same? Well, judging from what you've seen, probably not now. It doesn't take very long. The problems don't even need to get all that complex for the code to start getting kind of different between everybody. They'll all function the same way, but the code is going to be a little different. Now, this example, the first example, and the example with the else are all actually terrible ways. They're fine, but they're actually kind of like funny ways to write this function. And it's actually a bit of a joke in programming about why this is a weird way to write this function. I'm going to go back to the way it was with the 2 returns. Oops. There. This is kind of a funny way to write the function. There's nothing wrong with it, but when people see this, they laugh at it and go like, huh, you did that thing. Let's look at this code for a second. Let's say I gave it -1. On line 2, I ask, a number, which is -1, is a number less than 0? True. And when it's true, what do I return? Okay. But now let's look at the case of when it's 1. Is a number less than 0? And when it's false, what do I return? So if the expression a number less than 0 evaluates to true, I return true. I check. If this evaluates to true, return true. And then necessarily, if it didn't evaluate to true, it's false, return false. So if it's true, return true. If it's false, return false. Well, why don't I just do this? There. Look at that. Isn't that nicer? I'm seeing people look at me like, wait, what? Let's follow the code. When in doubt, what does the code say? I give it -1. I ask, is a number less than 0? Come on, wake up. Is a number less than 0? So what gets returned? What about when it's 1? Is a number less than 0? What gets returned? Oh, okay. The joke in programming is, if you ever see something that's like, if true, return true, if false, return false, well, just return the result of the expression you're checking. There's no need to check if it's true in order to know to return true, and false to know to return false. If it's true, it's true. If it's false, it's false. There's no need to do a check. You just do the comparison check first, and then you're good to go. Is that clear, or are people kind of scratching their head? In fact, the example down here with the true equals true is another similar thing people will make fun of. Checking if true is equal to true is kind of silly. Because if true equals true, what's the result of that expression? True. If I ask, does false equal true, what's the result of that expression? False. There's no need to even check the comparison. So really, is negative, that's returning true or false. Now, in the context of these tests, writing does true equal the result of this, I say is a good thing because it makes the test very explicit about, okay, the result of this should be true. But perhaps that's neither here nor there right now. Any questions about this is negative? Did anyone do it any other weird, wild way? I mean, if it worked, it worked. Okay. Now, compound conditions. When we make use of an if statement, the if statement only cares if the result is true or false. You could have a giant expression, but if it evaluates to true, then it runs it. If it doesn't, it doesn't. That's all it cares about. All that matters is the final Boolean value that it gets evaluated to. This means that we can make use of more complex compound statements, expressions, for our if statements. We can use arithmetic operators, Boolean operators, comparison operators. There's a lot of things we can do. For example, 3, 5 divisible. Here's a function that checks if, well, what's it say? Checks if a number is divisible by both 3 and 5. If it is, return string, it is, otherwise, nope. Maybe it should have just returned a Boolean, I don't know. But this one, it returns a string for whatever reason. Now, there's one thing here I want to point out. Who here has seen that percent sign used like that before? One person, 2 people, 3 people, 4 people. This is an arithmetic operator that we use, but it means like remainder. It means do the division and tell me what's left over. So if I asked you, what is 5 divided by 2? What's the answer? 2.5, right? But you're using decimals. Go back to like grade 3, grade 2 when you learned about division. If I ask you that, what is 5 divided by 2? 2 with 1 left over, right? We've got 1 that's like, you know, the odd man out. 5 divided by 2, if we do integer division, is 2. 5 mod, that's what we call the percent sign, modulo. 5 mod 2 is 5 divided by 2, but I want the remainder. So 5 mod 2 equals 1. If I were to say 3 divided by 2, what's the answer? One remainder 1, right? Like we can take a 2 out, but we're left over with 1. What's 3 divided by 3? This is not a trick question. I hope you can remember what 3 divided by 3 is. 1. But what's left over? 0. There's 0 remainder. If something is evenly divisible by something, it won't have a remainder. What's 9 divided by 3? What's left over? What's 12 divided by 3? What's left over? What's 13 divided by 3? 1 remainder, yeah. So mod is all about the remainder. So when I check if a number mod 3 is 0, if the remainder after doing that division is 0, I can conclude that that number is divisible by 3. And then there's another one, a number mod 5. If the number is divisible by 5 with no remainder, it's evenly divisible. The words are losing meaning. Divisible by 5. If the remainder is 0, it's evenly divisible by 5. So if we can divide the number by 3 and there's no remainder, and we can divide the number by 5 and there's no remainder, then it's divisible by both 3 and 5. Like, let's take 15, for example. What's 15 divided by 3? What's left over? Okay. What's 15 divided by 5? And what's left over? 15 is divisible by both those things. Great. So we can compound these questions to make more complex questions. Now, that said, be wary about how complex your if statements get. There's no rule, there's no hard rule that says if you have 3 ands, it's too big. No, because it really depends on the context. But here, I think this is safe to use an and, right? Because it's very clear on what it's doing. But, yeah. Oops, I think I accidentally went, which way? There we go. Cool. Yeah, modulo operator effectively does division and returns the remainder. For example, 10 mod 3 is 1, since 10 divided by 3 is 3, remainder 1. Cool. Okay, this just describes what we just said. Cool. Any questions so far? All right, so a very common pattern is if some condition is true, do this. If that condition is not true, do that. That's a very common pattern. Do this or that. So with an if statement, the examples we've seen so far both had a return at the end. But let me show you a quick example. When I hit run, we see starting inside the if, outside the if. Why? Well, A is 5, print. So let's execute this code one line at a time by hand. All right, A equals 5, great. Print starting. Okay, that's what we see starting. Then we check if A equals 5. Well, it does. So we go inside the if statement, and then we print out inside the if. So we see inside the if. And then we're done the if statement. There's only one statement in there. So we return to the flow immediately after, and we see outside the if. A single if provides a way to have a divergent path that can come back. Okay? If A does not equal to 5, does not equal 5 if it's 6, we only see starting and outside. You agree? Nothing crazy. It's just all about the flow of the code. But sometimes we want mutually exclusive things to be run. I don't want it to be like, okay, if A is 5, do this. If it's not, just carry on. And then when we're done this, it carries on at the same part. We don't want it to branch and merge. We might want to actually have like mutually exclusive things being done. We want to say, okay, if A is 5, I want you to do this. If it's not 5, I want you to do that. But with the single if, we're kind of in trouble here because I couldn't really have like an alternative flow. I could if I had another if, but not quite really in practice. We have no way to make it like if something, do that, otherwise do this. So this right here is a very common pattern. Here, if x is greater than 10, it will only ever run do something. If x is not greater than 10, it will only ever run do something else. Neither way, no matter what value of x is, it'll only run one of those two functions. Never both. where if I had, let's go back to a single if. Imagine I had the function, okay. If a is 5, I call do something, and then when I'm done, I also do something else. If a is not 5, I only do something else. But with the two if statements, we can have mutually exclusive execution, right? If true, and then if not true, do something else, right? So only one of those two functions will be run. Do we agree with that statement with this particular code? It's not possible to have both run because x is either greater than 10 or it's not. It can't be both. Because this pattern, this if true and then if not true, because this pattern is so overwhelmingly popular and common, we have a shorthand for it. We use a special word called else. That means effectively what I just showed you. It means if x is greater than 10, then if x is not greater than 10. That's what the else does. It's syntactic sugar. It's just nice syntax to simplify how the code looks, but the functionality is the same. So if x is greater than 10, do something. Otherwise, do something else. This does the same thing. Only one of those two pieces of code will get run. The do something will get called, or do something else will get called, but never both. So this if and else, that's how we can have not only a branch, but we could start to make multiple possibilities in terms of what to do in a situation based on the decision we're making. Yeah. And what's nice here too is, we write less. I always like writing less code. It's intuitive and easy to understand and read. Less stuff to read is kind of nice and clean. But another thing too is it's not as prone to errors, right? If I'm writing that expression again but putting a not in front of it, I can mess that up. If I type else, that's harder to mess up. So it's also less prone to errors, which is nice. Now, here's an activity. Write a function called hail that takes an integer as an argument. If the integer is even, return the value of that integer divided by 2. If it's odd, return the value multiplied by 3 and with 1 added. In other words, given a number n, return half of n when it's even and 3 times n plus 1 when it's odd. Don't forget about that mod. That could be handy for checking if something's even or odd. If something is evenly divisible by 2, is it even or odd? What would you say? Even. Yeah, okay, there's your hint. Raise your hand if you're done. Raise your hand if it'll be done in 30 seconds. Okay, keep at it. Okay, who wrote it like the way I did? A little bit close? Yeah, I could write this very differently and get the same functionality. I'm going to write it 4 different ways just to show you. They're all going to function the same. This one has 2 returns. I could just do this, though. I really don't need the else. This will still work. Because even though if the if statement on line 2 runs, the code would continue exiting outside. The code would continue executing outside the if statement once the if statement's done running. But because this isn't a function and it sees a return, it immediately stops the execution flow and returns to where it was called, meaning that code on line 4 can never actually be run if a return is hit before it. So this will function the same way. I could do it like with the start with assuming it's even. A number times 3 plus 1, or assume it's not even. And then we can say, okay. Nope. I could do it like that, make use of a variable, only have 1 return. Or even, I could do this. That'll also work. I mean, I just wrote 4 variations of the same function. They're all very similar, slightly different syntax, but the functionality is the same. Who here wrote theirs along the lines of one of the ways I did mine? Yeah. Did anyone do anything wildly different? If you did, I want to hear it because it'll be fun. No? Yeah? What'd you do? So what did you have after your last else if? The return? Okay. All right. Typically, you would want to end an else if chain with 1 final else. So if you're missing a final else, what do you do if it's not even and not odd? That's what you would put in that else, which of course isn't really valid. Cool. Okay. So here's a variation of smush. Let's go back to smush. Here's smush using an else. There. All the tests pass. So instead I'm using an else. I mean, it's arbitrary. It really doesn't matter. There's no right answer. But I'm curious, who preferred the first one or who prefers this version, the one that makes use of the else? Raise your hand if you preferred the first one. Raise your hand if you like the one with the else. Oh, okay, all right. It doesn't really matter. Both are fine. I would argue that perhaps the one with the else is a little clearer. But really, that's, no one's really going to complain too bad about that one. But kind of neat, right? That would be the 4th way to do smush, which would be similar to how I just did 4 ways of the Hale function. Here's Smush version 3. It puts the returns inside the if and the else, instead of having a final one at the end. Who prefers version 3 over the if-else with the return at the end? No one? All right, that's fine. You do? 2 people? Okay. Yeah. There's an argument. People will say, you know, it's better if your function only ever has 1 return. It's easy to look at your function and know exactly like where it's going to exit. It's not good to have multiple returns because then your function might exit from multiple places. Some people feel that way, and there's nothing wrong with feeling that way. And perhaps they're right, but in general, people tend to not really care that much about that. It's entirely fine to do it this way, or it's entirely fine to have a single return. Whatever, it doesn't really matter. Whatever you find more better, do that. It's not more correct, and it's only here, I'm only showing it to show you how, like, yeah, you could implement this however you want, really. Just make sure it's good code and it's correct. So any questions so far about anything? Everyone? Yes? Yes. Absolutely. In fact, that brings me to the next question. But we have to be careful. Letter grade broken. Ignore the fact that it's broken. There's nothing stopping us. Excuse me. There's nothing stopping us from having a million if statements. We could do that. I'm going to take this code. I'm going to get rid of the doc string only for the sake of clarity. But take a look at this code, and the first thing I want you to do, I'm going to give you a moment to actually look at this code, let it sink in. The first thing I want you to do is look at this code and come up with what is it supposed to be doing. And 2, see if you can tell me, if you can think of what's wrong with this code. Just, I want everyone to take a moment. I'm going to give you a couple minutes, actually, to think on this one. Maybe you find it obvious, but maybe not. Suppose right now, let's talk about what it's supposed to do. Well, you know, you give it a grade, like a % grade, and then it tells you like what the equivalent letter grade is, right? If it's above 90, it's an A+. If it's above 80, it's A. If it's above 70, it's B. Above 60, C, and so on, right? That's what it's supposed to do. And let's do a quick test. If I give you like a 51, you know, I see D, right? Raise your hand if you think you know what's wrong with it. Raise your hand if you have no idea. I'm confused. People, that sounded like it should be a one or the other question. Let me put it this way. What will be the answer if someone gets a 99? Here's what I want you to do. Everyone take a minute. look at the code. What does the code say? I'm going to call it with 99. I'm going to add a 99. I'm not going to hit run yet. You're going to run it in your head. There's no trick question here. There's no trick question. The one silver bullet is, what does the code say? Follow this code. I put in a 99. What would get returned? Take a minute, pardon me, and think about it. And then I want everyone to have an answer in their head, and then I'm going to hit run, and we're going to see if we were right or wrong. Okay, you got your answer locked in your head? Let's see. D. Raise your hand if you were right. Raise your hand if you were wrong. Be honest. One person's wrong. So let's follow the code. We're going to do this one line at a time. There's no tricks here. Letter grade broken, 99. So what value does percent grade have? So is percent grade greater than or equal to 90? Perfect. So then letter grade is assigned the value A+. Then I ask the question, all right, is percent grade greater than 80? True, because it's 99. So letter grade is now overwritten with the value of the string A. Is letter grade bigger than or equal to 70? Oh, now it's a B. Is it greater than or equal to 60? Yep. How about 50? So it gets set to D. But because it was set to D, the else was skipped. So it didn't get assigned to F, because the if and the else are mutually exclusive. A chain of if statements is not. Each if statement will run independent of one another. That's why we see it break. The quick fix, because we're running out of time, is to make them elifs. Whoops. Which is a short form for else if, which makes all of it mutually exclusive. Only one will ever run. A+. Cool. Yes? If you put a return in there, it would work just fine. We'll pick up here next class, whenever that is.